In our previous lecture, we were discussing on design principle, and we had discussed around 5 principles. And basic principle was the basic principle of design or every design is that it must have minimum natural stress, and at the same time we can tell that any design must have minimum bends, joints, which actually create stress. That was the first principle. Second principle was we should make a design which will ensure use of single metal. And third point was, in case use of single metal is not allowed, we have to use more than one metal. In that situation, we have to have a design where contact between two metals can be avoided. And number 4 was, if contact between two metals cannot be avoided, in that situation, we must take or choose metal in such a way which will provide larger anodic area and smaller cathodic area. And if it is not also possible, in that situation, we must go for metal which are very close in the electrochemical series, so that potential of the electrochemical cell will be minimum, intensity of electrochemical cell will be minimum, corrosion rate will be minimum. In our last lecture, this thing we had discussed. Now we are actually starting with point number 6. Now let us take another situation where use of two metal are must and their contact is unavoidable and at the same time undesirable. In that situation, we must go for a design which will provide the provision of inserting an insulator so as to keep both the metal away from each other, that is disconnected, so that electrochemical cell will not be produced. Number 7. Suppose two dissimilar metals are being used to make a design. In that situation, anodic metal should not be coated, because if it is coated and it is connected with a dissimilar metal, and due to any reason, if any part of the coating gets destroyed, it will initiate enhanced localized corrosion, and therefore that kind of thing we should avoid. Number 8. Actually, any design should avoid inhomogeneity. What do you mean by inhomogeneity? Cleavage should not be there. So any proper design must be free from cleavage between the adjacent part of the structure, even if single metal is being used, because cleavage will create concentration difference, and which in turn may produce differential adhesion corrosion. Then number 9, the design. In this context, I would like another thing. Rivet and bolt. Here it is shown here. Rivet and bolt are not used in such a situation, because you see there is a cleavage, and because of this cleavage, inhomogeneity will be developed, and therefore this kind of bolt joint but rivet is not being used and suitably replaced by actually bent weld. There is no actual cleavage like that. The gap is filled, and therefore this kind of design will be preferred. Now next point, the design should be such that it will provide adequate cleaning option and blushing of the critical part, so that deposition of dirt can be avoided, because we know that if dirt deposition is there, and therefore it will definitely produce a stagnant area, and stagnant area initiate anodic area production, and therefore any structure having sharp edge, sharp corner like this type of corners should be avoided to avoid formation of stagnant area. Number 9, no, number 10. 9 is over. Number 10. We should go for a design which will ensure long leg. If there are two designs, this is one, this is another one. In this case, there is no leg, and therefore this area there is no air circulation, and this part will become very, very stagnant. But here, therefore, free air circulation is possible, and therefore this kind of design will be best design, and this kind of design will be considered as poor design. And therefore every design should be provided with long legs so that air circulation is possible to restrict formation of any actually stagnant area. Number 11. This point is very, very important. The design we should propose should ensure uniform distribution of corrosion liquid flow, as stagnant area as well as turbulent flow and high rate by high velocity, they can initiate rate of corrosion. One thing I would like, stagnant area we have discussed so much. If we want to talk about turbulent flow, let me discuss about it. Suppose this is a river having very actually high wave. If we want to reduce the intensity of wave, we will put an obstruction over there. In this situation, you see, this is the obstruction. Now what will happen? Now this structure will get coating over it. Now you see, if it is called turbulent flow because it is hitting a particular space, and due to repeated hitting, there is every possibility the coating we have applied from here will get removed. And if this thing happens, this uncoated area will become your anode, making rest of the area cathode, and therefore this thing we should take care of. And last point we should discuss, that is the basic principle involved in any design, is that the design should be such that no part of the design will be exposed for extra stress. Because if there is any extra stress at any part of the design, so that stressed area will become anode, and therefore we have to ensure that the design we are going to propose must have uniform in terms of stress. So these are the design principle. If we take care of this principle, so to my mind, to a great extent, rate of corrosion at the beginning can be monitored and controlled. Please go through the video very carefully. If there is any doubt, get it noted, and we will clarify your doubts in the next